we'll touch on that today. What I'm alluding to is you might have heard of Cloud Foundry, and you might have a picture in your mind or an understanding as a snapshot in time of what that actually is. Well, for all of you who have looked at Cloud Foundry in the past, suspend what you know about that technology, because we're going to start showing you some things that are an evolution of what Cloud Foundry means. Today is really just one piece of that explanation.
Yep.
And we're going to talk about building Docker containers and running them in Kubernetes today.
Sure. So, yeah, I think before we get started, we have a lot of different talks in Spring One platform, which we do every year. This year is in Austin, Texas on October 7th. We have a talk on Native Buildpacks over there as well, but we have a bunch of other talks around Kubernetes, platforms, DevOps, Spring development. So a lot of different tracks. If you are interested in the conference, please go ahead and sign up and try to come over.
Yeah, and if you like music and beer, it's probably a good timing comparative.
Yeah, the Austin Music Festival is like the weekend before as well as the weekend after, so you can attend the music festival as well as part of it. So a little bit of agenda, what we're going to talk about today, right? So we're going to talk about a little bit of history of Buildpack and what its roots are, where it is in use currently. We'll talk a little bit about the Cloud Native Buildpacks project and what it is doing. We'll touch upon one of the case study about Buildpacks to kind of give you an idea what it is trying to solve, right? I mean, is it just some closed source to image project, or is it something which is something real, something open source, which can be used really to improve developer productivity and manage operations at a scale? We'll do some demo on the Cloud Native Buildpacks. We'll do a demo on lifecycle of a lifecycle pipeline through a CI/CD tool called Concourse, using those packed constructs. And then we'll touch a little bit on the Native Build service, which is the enterprise version of Cloud Native Buildpacks, packed with certain little things, which makes it enterprise ready for consumption. So we'll touch a little bit about Native Build service and what it brings along with Cloud Native Buildpacks.
Of course, we're going to use Azure Kubernetes.
Yeah. So the entire demo which we're going to do today, some of the packed stuff is local, but our Concourse lifecycle and Native Build service demo is running on Azure Community Service on AKS. Sorry. So what's the history of Buildpack? Buildpacks started, the concept was first introduced by Heroku in 2011. And Cloud Foundry Foundation and Cloud Foundry platform picked up that Cloud Foundry, the Buildpack construct, and started using Buildpacks for building containers, right? And Cloud Foundry and other distribution of Cloud Foundry as well as Heroku has been using Buildpack for almost 8 years now. Lots of large customers using it in production at scale. For example, Home Depot is using like 30,000 containers across the lifecycle stages, using the constructs of Buildpack to build and run the containers. And so it has quite a lot of history. It has quite a lot of validation in the industry about its usage, at scale. And what Cloud Native Buildpack is doing is taking that construct, which was kind of built within the Cloud Foundry and Heroku platform, and bringing it out as a standalone project, right? And then kind of building a product out of it. And it was accepted as part of CNCF Sandbox project. So it's open source, Cloud Native Computing Foundation, part of that foundation, and it's trying to bring that building containers at scale as a standalone project, so you can run it anywhere on any Kubernetes.
And for folks who aren't so familiar with Buildpacks, these are the runtimes for various languages. So Java, .NET Core, Ruby, Go, Python, PHP. It's the thing that takes your artifact that you write as a developer and produces an image, a container image, to be run in the platform somewhere. previously Buildpacks inside of the Cloud Foundry historic view of the platform. That was all kind of baked into the platform, and you really didn't have control over it. And plus, it didn't produce a Docker image that a lot of people wanted for portability to take it to wherever. And so the idea here is to take what was good about the Buildpacks that allow you to produce a Docker image so that you can achieve that portability. So people are
So to touch upon a little bit of like why Buildpacks, right, and how it helps. What factors bring in or what are the benefits of using Buildpack over your standard way of probably doing Dockerfile and building your images out of Dockerfile? So one important thing which we come across a lot of places is it provides, you always have that challenge of that developers are building their images, they're trying to figure out what golden image to use, what base image to use. Operators and the ops side is trying to enforce certain golden images and base images. And you have that drift of like, okay, I want to use this, but how do I go get approvals and figure out how to get things done? So, and a lot of times the side projects can go and start pulling a lot of different kinds of images in, and then you have kind of a weird scenario where when you're trying to get it to a real project, you get into stuff with your ops team and figure out how to do it, right? So this friction between the dev and ops teams when you're building your own Docker images through Dockerfile. We're trying to solve that friction using Buildpack. We're trying to bring kind of a balance that now devs don't really have to worry much about what goes in the manifest of the Docker image as part of the rest of the layers which you want as a supporting layer for your application. You care about the application and you just worry about your layer. You build your application and you push your application across. So, and the rest of the layers are kind of brought in by the ops-driven Buildpack, right? The idea is that ops is going to drive the operating system and the application server layers and give it to you, and devs is going to just push the application and it will marry that layer together, right? So that brings in that operational, like takes away the operational burden from devs and brings in that collaboration between the dev and ops in that case. And one of the biggest factor which comes along with it is the security and compliance, which ops is pushing towards, right? I mean, the reason you have that tussle between the ops and dev when about using different kinds of base images and different kind of image layers is that ops and security is driving those security and compliance requirements, and dev just wants to go fast, right? And to how to bring in that compliance and security benefit in such a way that now devs don't have to really worry about what they're putting in their image, because they just are putting the application in their dependencies and pushing it across. Ops is driving what goes into the rest of the image layers so that they are managing the security part of it, they're managing the compliance part of it. The security team is happy that they're driving some of the standards around it. It also helps in a lot of data operations pieces. We will touch upon some of the use cases on. We'll touch some of the use cases on the data ops it solves. For example, the use case which we look at is how do you go about patching vulnerabilities in your applications which are running in production at scale with your image layer, and how do you go about it, right? And how Buildpack enables the updates to your Docker containers, Docker images at scale, at speed. So it helps you in managing those as well. And along with that, not just the OS level, it could be OS level security patches, it could be application server level security patches. And how do you go about managing that with, like, for example, if you're deploying at scale with like your multiple 100 apps, in case of Home Depot, you have 30,000 containers. How do you go about patching 30,000 containers, right? And how you go about building those 30,000 containers with different application development teams. So that's where Buildpack can come in and help. We'll bring in that synergy around patching without developers getting bogged down by rebuilding the images through Dockerfile. It also does a really good job of updating your image layers, updating only the image layers which are changing or which needs to be updated. so that you're not rebuilding the entire image every time, right? So there's a lot of efficiency built in as part of the Buildpack project that it increases the efficiency of updating your image in your registry. So those are some of the things which drives the Buildpack project and the benefits of Buildpack, which are being used by a lot of enterprise customers today within Cloud Foundry. And with Buildpack, Native Buildpacks project, we're trying to drive that across the board on any Kubernetes.
But this compliance requirement, does it make sure that PCI and HIPAA compliant all like that? What compliance requirement will make sure that?
So what I would say is like compliance requirements around what patch level you're running on, what kind of I would say what kind of application server patching you have to have on your running applications, right? Some of the HIPAA requirements which you're talking about, like whether your data is being stored, if your storing is encrypted or not, whether you have sensitive data in plain text or not, that's more of the app level concern. What compliance requirement we are talking about over here is more of at the application level, what all security things which has to be there to be compliant.
Like what are all the steps you have to do to secure the container and secure the operating system?
And address vulnerabilities. So I think one of the things with PCI is that you have to know what is the current state of exposure of apps that are running at any given moment, and what's the plan to remediate, especially when you know there's high severity vulnerabilities. And primarily what we're talking about with Buildpacks here, outside of the platform and just using the Buildpack service, we're primarily talking about how do you address vulnerabilities in the layers that make up a container, a Docker container. Do it in a way that you can roll through that quickly when something like Spectre meltdown or Heartbleed, those vulnerabilities that are found in Java or container meltdown. Without having a consistent process, and it's owned by each development team in a different way, and their own pipeline, they have their own alerting mechanism. There's no guarantees that the operations team can report that all apps are compliant or what state they're in to begin with. So there is the visibility, but then there's also the process to get it done quickly.
So that's how the Cloud Native Buildpacks was born, as we were talking about the history through it. It builds the OCI standard portable images, which you can run anywhere. In any Kubernetes, you can run it in local environment for fast troubleshooting. It was developed as part of in partnership with Native and part of CNCF project. And if you see over here, these are the different kinds of buildpacks which is already supported. It's .NET. So I know that Java, Node, Ruby, Python are already GA. .NET Core and PHP is on the works, as well as Go is on the works in terms of on the Cloud Native Buildpacks side. But these buildpacks are already being in use in the Cloud Foundry foundations by a lot of customers. So we're just taking it out and making it as part of the Cloud Native
The point about .NET Core is .NET Core can run on Linux-based hosts. Following the release of the Linux service, we'll also be working on the Buildpack for .NET ASP framework apps running on Windows hosts. That today is something that we do already with the Cloud Foundry platform. So Fiserv is using that Buildpack. So right now, the build service will focus on Linux hosts that can run containers. .NET Core is where you run that. I guess we'll play about the .NET stuff.
Sure. So let's quickly look at one of the case study, right? So the OpenSSL CV came out. And so if you have an app, you have a Node app, you have the app in Node.js, and you have the OS packages. And consider that when that CV came out, the OS package has vulnerability and you need to patch those, right? How would you go about it? Say you have 500 Node.js apps running, and on September 26, 2016, now all of your 500 Node apps have vulnerabilities. If the Docker files And this is one of the examples. If your Dockerfile is done wrong, you might have different OS package layer across your applications, right? And how much time is going to take to kind of patch all these different OS layers through Docker files and rebuilding them and deploying them. The mitigation for this kind of setup is like months, maybe even years, right? And then your application is running with vulnerability for so many months and years in production. If the Docker files are done right, when it's operator managed, you generally have a base golden image, right? And then you have those all of the applications or all the apps, node apps are using that base golden image. In that case, iterative mitigation is better, but you still have to do a lot of rebuild. You have to rebuild all those 500 application images. You have to test and redeploy. So it's better than the previous scenario, but you still have a lot of rebuilding to do before you can go and do and test and redeploy. So here's what Buildpacks IO does in that scenario, right? And if you look at this example, the way Buildpacks build the Docker images is you have the app and the app server dependency, the node dependency, and you have the OS package living as a separate layer attached to an API compatibility guarantee, which comes with, in this example, CF Linux FS3, which is the Ubuntu-based Linux image, Linux layer. It has an API compatibility guarantee with the upper layer. So with the help of Buildpacks, we are able to, the way Buildpacks does is it associates the layers through something called image manifest. So there's a symlink between the application layers, the node layers, as well as the OS packages layer. So it's not statically built as one image. It's built through symlinks through an image manifest. And when this OS package is vulnerable, you push in the new OS package to your repository, and all you do is change your update symlink. And as part of that push to the repository, and that push itself will start updating the manifest file for your applications. So essentially, and this happens directly into the Docker registry, right? This was kind of brought in by the Docker registry 2.0 version, 2.0, 2.1 version, which supports the cross repo blob mount support. So instead of now rebuilding all these 500 apps locally and then pushing it across into the repository, your Docker registry, this is changed right in the Docker registry, and now all your application images are up to date and mapped to the right OS version, patch version. What this does is the build process has gone from building 500 images to pretty much pushing one layer of OS package and sending an update to the image manifest. Now all your applications have the updated layer. You're still required to go and deploy these apps. What Buildpacks is helping you is in getting your images updated and patched, but you still have to go through the deployment process of it. But at least it is saving you a lot of time and process, and it's also mitigating the risk of when you're rebuilding the image, are you doing some screw up with your application layer, right? Did something change in your Dockerfile which change the behavior of your application? In this case, you're not rebuilding the image at all. All you're doing is just changing the symlink to your OS package, and all your applications are updated with the guarantee that app will not change, right? Instead of rebuilding 500 application locally or through pipeline and then pushing across, you have the risk of your application might have changed, right? Or some properties within the application might have changed, which is kind of guaranteed over here that you're not rebuilding it, you're just changing the links. So quickly touching upon like what are the parts of Cloud Native Buildpacks, right? You have something called as Pack CLI, which you use to build your Docker images. It comes with a builder. Builder is you can say set of configuration telling what all different types of build packs you can support through a builder. In this example, we have the Java, Ruby, Dockerfile, Python, Gradle, PHP, and all these build packs are available as part of the builder. So you can configure what do you want in your builder, right? You can say that for my application group or for this application group, I have a Java and Node builder as part of my deployment, or as part of something which you will make available to your developers. So when they go in and build their applications, they'll be able to build Java and Node applications. So it gives you a little bit of configurability that what kind of build packs you want to allow developers to use, right? And they can then use deep builders within that, or build packs within that builder. So what this shows is like, what are the different things which happens as part of the build pack? When you use build pack, what it does as part of that. And we'll also go through the demo to kind of walk through these steps. But as part of build pack execution, when you run the build pack to build a Docker image for you, it does detect. And by detect, it's trying to figure out what kind of application is this? Is this a Java application? Is there a Node application? What kind of build pack I should be using for this application? That's the detect phase of the build pack run. After it has detected, it analyzes if there is any cache which is already there, which I can use, what other things I can bring in with it. So that analysis step is done as a second step. Third step is where it's actually going to build the Docker image for you. And fourth step is export, where it's going to export that across to your Docker repository. And so when you run through the pack CLI and try to build the Docker image, you go through these 4 steps. And there's actually a 5th step where it will try to cache whatever it can cache, so that when you run this thing again, at the analysis fail, it will catch that cache and say, okay, nothing has changed over here, I'm just going to use the cache. So yeah, this is just an explanation of that. It does document selection, checks the metadata, and see if it can use something for previous builds, builds the image, and then exports the image. So some of the things which it brings along with that, which we've been talking about, is it rebuilds and uploads only the necessary layers. It is not going to rebuild the layer that is not needed or which is not changed. It builds the OCI compatible image. It uses the Docker registry v2, so you're able to do that cross-blob mounting. So instead of rebuilding all the layers or rebuilding from the Dockerfile and then pushing your image to the registry, it can directly change the symlink to the amount of those layers in the image manifest. So it does a lot of fast builds. It does minimal data transfer. And also helps a lot in use cases where you have edge scenarios and you have pretty much like for example, we're working with one of the customers. They have like 60 kbps network link for the entire edge center. And out of that 60 kbps, you can use only maybe 20 or 30 kbps. So in those kind of scenarios, your data transfer speed matters a lot, right? It gets to a point where every kbps counts at that point, right? So make sure that you're doing minimal data transfer, you're doing fast build, and so it's using the concept called rebasing to achieve that. So let me quickly do a demo of pack. And let's see. So I have a sample node app over here, right? Let me get this Docker file first. So if I do it in a traditional way, just an example, I'll do it from node. I'll copy my application to the directory, and then I'll run npm install app, right? So if I just do a simple way, docker build -t, what should you call it? Sample node. And what I'm trying to kind of showcase over here is if I do this in my in a regular way. Now, when I go and update my application, so if you think of it, I'm updating only the copy sample node app portion, right? And if I have to rebuild this application, what will happen? So when for sure, it's not going to go through all these pull and extraction from the second step, but do you think that the run npm install app should change? That layer, I'm not doing anything to that layer, right? I'm just going to update my application. Right, so if you look at over here, this is the SHA for run npm install layer. This is the SHA for sample node app. So now if I go and get into my application and change this application, right? And if I build it again, if you'll see, this layer and this layer run npm install has changed. Why does it have to change? If you think of it, this layer, I've not done anything in this layer, but there has to be change. Had to change as part of my Docker install. So there are several scenarios in Dockerfile when you make changes to your app, the other additional layers, which kind of cascade along with it, changes as well. And in your rebuilds, you kind of rebuild those layers, right? In case of Buildpack, now I'll take an example of Buildpack. If I go and do this, first time around, Buildpack is gonna build all the layers, but once it has built it once, it will reuse, it will change only the layer which has changed. It will not going to change any other cascading layers. It will reuse all the cascading layers. So that's one of the benefits of Buildpack, which kind of is really important when you get to scale, when you get to like 500 containers or 30,000 containers. Those additional layer rebuilding matters from time perspective, from data transfer perspective. So I do pack build, stretch. So when you do the pack build, you have different options which you can do. One of the options is you can publish this. So if I can just do pack build and we'll build it locally. And if I do publish, it will publish directly to the Docker registry. So as part of the build step, it can also publish it to the Docker registry. In this scenario, I'm just going to do pack build, right? And I'll just give it a name, sample pack node latest. And that's all I had to do. All I needed was the pack CLI. And once I had the pack CLI, I was able to do pack build and give it the image name. So from here it started. What it's doing is, as I was saying, that it goes to the detection phase. At this part, it's trying to detect what's the best build pack to use for this application. And after that, it figured out, okay, it's a node app, so I'm going to use the npm build pack. Restoring is more of like trying to find out. That's the step where it tries to find out if is there any cache which is already there for some of the layers which I can reuse. And it analyzes if there is an existing image. Can I reuse something? In this case, it did not find anything because I created a brand new image. It went through the build process, the npm install process, and then after that, it's going through the export process. And so exported all the layers. And after that, it cached all the layers. In this scenario, if I go and look at my Docker images, I have the pack node latest over here. And in this scenario, if I now go and change this and say, hello, Pacman. And if I run this again, I tried to turn it off, it doesn't turn off, right? So if I run it again, it is going to reuse all the layers, except it's going to just do the replacement of the app layer. It's not going to do the replacement of the install layer because that layer is same. And I'm going to do, I'll show you the, it's trying to detect, found the npm buildpack again. It's restoring the cache layers for node modules. It's analyzing the image, it's using the cache layer. Rewriting the meta layer for engine, and then if I go back here, it'll say it's reusing the layers where it was already there. So where's the app? This is the, yeah, this is the app layer. So this was the only layer where it recreated the layer and exported it, but it reused for all the layers, right? And this is just a simple example. Simple example on a very simple Dockerfile, like how in case of Dockerfile, it will a lot of times rebuild a lot of cascading layers, but Buildpack kind of makes it efficient and rebuilds only the layer which is needed and detects and changes only those layers and updates those layers. It also gets to a point where, for example, when you're writing your Docker files, every developer has different styles, right? And they can write different set of script commands in different ways, right? Buildpacks drives a lot of efficiency in those things as well, right? In case of a developer who is trying to do a get and then a shell script run on it, can run multi-line Docker run steps, versus Buildpack is optimizing that because it's kind of driven by the system, right? So there's a lot of optimization which also comes with Buildpack versus when you do it manually through Dockerfile, right? You can go and analyze and optimize your Docker files, but think of it, when you get to like 30,000 apps, how many application developers you can go and optimize those different things with, right? So what Buildpack is doing is taking the entire Dockerfile authoring away from developers and saying, you're building your application layer, compile and build your application layer, and let Buildpacks build the Docker image for you, right? So it's kind of optimizing rest of the layers along with that application through Buildpack project. So, so as a next step, what we're going to do is do a quick demo on how you can use this construct and run it in the pipeline for your deployments, right? And go through that. Let me do this. Let me also share this with you. And okay.
Any questions so far about what you saw, or I'm going to take it another step further now and put that pack command that Myresh showed you, and I'm going to use it in a pipeline. I'm going to effectively run the steps of the builder, the lifecycle of what pack does. I'm going to effectively run that as a task inside of my pipeline, and I'll show you how I do that.
And if you share your screen.
So I do have a repo if folks are adventurous and want to try some of this stuff out. Open that up real quick. First, I'll show you a little bit of explanation of what I'm going to demo here. So, has anybody in the room here seen Concourse? So you might know Jenkins, or you might know TFS if you're Windows.net. Various CI tools are out there, GoCD, Travis, whatever. Pivotal has a technology called Concourse. It's an open source CI/CD technology. I'm going to use that for my demo. It doesn't have to be what you use to leverage the Buildpacks. But this pipeline is going to go through a flow of building and testing. In this case, I'm using a Spring Boot app. I'm also going to run a vulnerability scan using a partner technology called Sneak. And then I'm going to Dockerize that Spring Boot app using the Cloud Native Buildpacks. And then I'm going to deploy it to both AKS and also PKS. AKS is Azure Kubernetes, PKS is Pivotal Kubernetes. So to us, it doesn't matter. I have Kubernetes here, I have Kubernetes there. At the end of the day, I want to take this Docker image that passed through the pipeline and run it in a variety of places. This repo for all of it includes the Java app, and there's a directory in there for the pipeline definition itself. So if anybody is interested in getting the full link, I can email it to you. But in this repo, you'll see things like the Java source, the definition of the pipeline itself, which is pipeline TKS is what I'm using here. And then what it executes are various tasks. And as you can imagine, based on that diagram I showed you earlier, these are the tasks that execute the vulnerability scan. These are the tasks that execute the build. This is a task that deploys to Kubernetes. And just really quickly, not to spend too much time on Concourse itself, Concourse is a YAML document. Concourse pipelines are YAML documents. And if I go there and open that up really quickly, I'll give you the YAML view of what's actually happening here. The way you use Concourse is you define resources. Resources would be things like a Git repo, or a Kubernetes destination, or it might be an S3 bucket to grab things. So resources are inputs and outputs to pipelines. Think of it that way. And then the pipeline itself is broken down into jobs. And within jobs, you have individual tasks. So in the case of build and test, I've got a task called test, and it references that task definition. And it needs the venues repo as input. That's kind of how you define pipelines in Concourse. Pretty simple. It is YAML. When you define those pipelines and take a look at what that rendering is, first I've got to send the pipeline definition out to my Concourse, which is also running in Azure Kubernetes. I stood up Concourse using a Helm chart that you can find in the documentation. But basically the way you set it is using a CLI. I'm going to set my pipeline. I'm going to pass it the definition of the pipeline and then my secrets. Secrets are things like Docker username and password, token for sneak, the kube config that allows me to push out to this Kubernetes instance. Those are what I'm storing in params, and I'm not checking that into my repo. So you'll see pipeline is the definition for the pipeline in the repo, but you won't see my secrets, obviously, in the repo. So I set the pipeline. It says it's out there. It's paused. When you first deploy a pipeline in Concourse, it starts out paused. So if I want to kick this off, I can either click into it and then click play, and that'll kick off my first instance of a pipeline build. And so that's going to take a little bit of time. I'm going to go through a scenario where I want to address a vulnerability that Sneak is going to call out for me, and I'm going to rebuild my Docker image and have it deployed. So this is Concourse is asynchronous. It works on polling these resources when it sees a change. The initial play of the pipeline takes a little bit of time. So it's queuing up work in a containerized environment behind the scenes to execute the steps in this pipeline. So
I wanted to ask, did anyone notice that there was no plugin involved over here to install any of these?
yeah, that's a good point about Concourse is compared to things like Jenkins or other CI/CD, once you have a Concourse running somewhere, you really don't have to tweak that installation of Concourse in order to run a pipeline defined for Concourse, because all of the resources that are needed by a particular pipeline that you develop is defined in the YAML, not in the installation of Concourse. So that makes these pipelines very portable to wherever you're running Concourse. Concourse on-prem, Concourse in Azure, wherever you might want to deploy and run those workloads. And one of the goals of Concourse also is that you can imagine big LCDs in a dev shop that are constantly showing you the feedback of how my pipelines are doing. When tasks are running within a job, you'll see this pulsing going on. So if I click into build, this is doing my Maven package for my Spring Boot app. So you can see all the Maven downloads, and I haven't optimized this to cache the .m2 directory, which is how you manage dependencies locally on your laptop when you're using Maven. I would want to cache that. I can optimize this pipeline to do that. So at the end of this build and test, it's going to build my Spring Boot app and run my Spring unit test in this task. At the same time, what's happening in parallel is I ran a scan on the code base. So what Myresh explained to you earlier was build service and Pivotal are going to take care of patching and CVE vulnerabilities up to your app. Sneak is an example of how you can address the app itself and the dependencies it's pulling in. So the output of Sneak is actually taking me to my account. Sneak is a SaaS-based solution, but it can be run air-gapped on-prem. They're a great partner of Pivotal. I go here and I see this particular app, and I have some high severities here. I see Jackson dependency. They're recommending that I update to 2993 to clear this vulnerability. So I know my pipeline is running, and that's great. I can let it go there while it's going through the build pack, and I'll review the output of the Cloud Native Buildpacks running as a task in Concourse. But in the meantime, I want to go and fix that vulnerability because I don't want to get a call from the security team the next time somebody finds a way into this app that I wasn't expecting. So I somewhere in here have Jackson Core data bind. I'm taking the default version. I'm just going to go ahead and override that. In Maven, Java, this is how you do that. Different ways to do this in other technologies, but NuGet has something similar in the .NET world. So that should force my dependency to the right version. I'm going to go ahead and save that. And once I save, I'm going to go to my changes here, and I'm going to commit that. Commit that, and then go ahead and push. Because of the way I have the pipeline set up, once that gets pushed out to my GitHub repo, that's going to cause another round of build test and vulnerability scanning to kick off. While we're waiting for that to happen, we can take a look at, similar to what Myresh showed you with Pack on his laptop, you'll see similar output coming from, just completed, coming from the task that I'm running in Concourse itself. So once again, you see I'm passing a certain set of build packs. I haven't detected whether I'm going to use any of those build packs yet. And I also look for a cache of whether I ran this previously. Concourse has a way of specifying a cache directory so that every time this pipeline runs, it can remount that directory and reference it for this build process. So the next time I run this, it will take the layers that I built the first time and reuse them, just like what you saw on Myresh's laptop. So it detected that I need OpenJDK and the system build pack, and now it's compiling the application. This particular setup with the Cloud Native Buildpacks, I'm pulling directly from the repo again. I can set this up so that the build packs use the jar file that was created as a result of my test, my build and test step in the task. But I'm just pointing it to the repo again. It's pulling the source. It's doing the Maven compile because it detected it's a Maven package. And somewhere down the line here, I get my my app layer getting generated after it does all this Maven fun stuff. So download, and we get down to build success. Great. Removing the source code. I don't want that in my container. Then it's going to add another layer called the JVM application build pack. And oh, by the way, this is a Spring Boot, so it's pulling in that dependency as a specific layer. It detected that in my POM. So there's special treatment here for a Spring Boot app. It saw that I was referring to Spring Boot parent 2.1.7 in my POM, and it said, all right, I'm going to treat that as a separate layer altogether. So if your POM is changing, but the Spring Boot version doesn't change, I'm not going to mess with that layer. I'm not going to have to push it. Auto reconfig for optimizing how you bind the services. And then ultimately my image was created and pushed out to Microsoft Azure Container Registry. If I go to my container registry, I can see that those things were published out there. I'm actually sitting on it right now. So if I refresh, I should have, refresh, see if I'm still logged in. Cruise line AKS, I think is the tag I used. And this was updated when? Last tag is 7/28. Yeah, that's the one that was just updated by my pipeline run. So that's great. I now have an image built. It's up in the registry. Probably in the meantime, it's already deployed out to both my Kubernetes clusters. And so in this case, I used what's known as a resource definition to point to AKS. So there's different approaches you can take to deploy Docker images out to your Kubernetes. This pipeline actually shows you two ways of doing it. We also have a utility called cap, which makes the treatment of Kubernetes deployment of applications a whole lot easier. So if I go out to my Kubernetes, cuddle, I need to know what's the IP address of venue service. Well, before I go there, how did it know to create that service in Kubernetes? And by the way, I'm talking about Kubernetes concepts now at this point, I realize. But there are some artifacts that are needed to deploy a Docker image as an app to Kubernetes. If you're not familiar with Kubernetes, you have things like the app deployment itself. Deployment is a YAML description of the app itself. There is networking to have ingress to your application over the network. It's called a service. I defined a service and a deployment YAML for this particular app, and it references that registry entry in the deployment. So in this repo, you'll see K8's folder, and you'll see deployment YAML. Ultimately, that's where it's picking up the image that I've been building here from the process. And I've also created a service that says, give me an external IP address and allow me ingress to this application over port 8090. And so now that I know what the IP address is from Azure, I should be able to go to the browser and hit this application. And there's my app. So not too, nothing sexy to see here, but let's go back here now, because I should have now run this pipeline twice, and my vulnerability scan should have updated Sneak. If I refresh this, hopefully that first one goes away. Oh, it didn't. What did I do wrong, Maharish?
Does it create a new,
New URL maybe? Like if it,
Oh, yes, it did go away.
yeah, it's a different one now.
Yeah. So now I have a different high severity listed up here. And I looked into this H2 database. If anybody does Java development, there is no fix for this one. But the good news is H2 is an in-memory database that's only used for testing. So, but you get the idea.
Right.
So now I've made my security teams a little bit happier because I've eliminated a high severity vulnerability. And the process that Maharish walked you through of only updating the layer that got changed, which in this case was the app layer, was what allowed me to do this in an efficient manner. So I'm trying to think if there is anything else with this demo that I wanted to walk through. Well, so one last thing I wanted to show you, back to the pipeline definition, closing these. So my pipeline is here. where I did the deploy, or where I did the build with the Cloud Native Buildpacks is this task right here, right? In that task definition is where I run, I'm referencing an image, the lifecycle task. So the inputs are the repo itself, and then within that task definition, there's a launch. And then you'll notice, like I said, in Concourse, you can say what directories or folders within the container that ran this task I want to have for the next time I run this. That's how I'm letting the Cloud Native Builder know that there were layers and there's a cache of those layers that were built previously, reference them and restore them in the process. So if I go back to the build, this would be my second instance. And remember the first instance said something about there's nothing to restore. There's nothing to restore. The demo gods failed me. This should say, and I'll have to look into why it's not saying it now, but for some reason it's not picking that back up. But that's the intent, and it did work. Damn it! Last time I did this. So anyway, any questions there? The idea was to take what Myresh was doing on his laptop, put it in a pipeline, and also deploy the app once it's built, with of course security scanning being done. So this is more of what end to end might look like. Where Pivotal is headed is we'll do CI with Concourse. We're going to do CD with Spinnaker. That's the part 2 of this demo that one day I can get to. So that's what I got for this part. I guess the next one is, so what we've shown you so far, the Pack CLI, I'm using the open source Cloud Native Buildpacks process natively in Concourse, still all open source. Okay, Pivotal, what are you doing with all this, and how do we get support for it? That's the packaging is called the Pivotal Build Service. That's the commercially supported packaging the stuff that we've been showing from open source. Yep. That's what's next, right?
So Mike, since Spring was a layer, like if you wanted to patch Spring, will it does that inside of the Docker registry then?
Yeah. So you're gonna kind of follow the process. What I did there is you found a dependency that needs to be updated in the POM. You have to rebuild the application. So in this case, it's a Spring Boot. The result is a jar file. All the other layers do not need to be updated. Only the app layer itself needs to be updated in the registry, and that's what the Cloud Native Buildpack's gonna.
But Spring Boot was its own layer, so it could have been.
And the app, so that's the app layer, is where the Spring Boot app itself is sitting. The dependency for Spring Boot parent is also treated as a separate layer. So they did take that one part of your POM and separate it out as a layer, but everything else is considered app layer.
So as Mike was saying, that Pivotal Build Service is the commercial enterprise supported version of it, and it's not just the along with the commercial enterprise version of the open source Cloud Native Buildpack and lifecycle, we add a couple of things, right? We add something called as we do as part of Pivotal Build Service. We are adding CRDs for your builders and your image configuration, which lives within Kubernetes now.
What does CRD stand for?
So CRD is custom resource definition. So is anyone aware of CRD or custom resource definition in Kubernetes? It's a construct which allows you to build custom things for Kubernetes to understand natively. So for example, Kubernetes by default has things like deployment or services or pods, right? So Kubernetes already understands those constructs. If I want to build something which is my own, a custom construct, and I want Kubernetes to understand those constructs, I build a CRD, but I have my custom resource definition and the logic what it will do, and we push that CRD to Kubernetes. Now, when I go spin up something which has the kind or type of what CRD I pushed, Kubernetes will understand that. and it will run that logic. So in this scenario, we build CRDs for how the image lifecycle will work and how the builders, which I was talking about in fact, that you have builders and builders as list of buildpacks. So that definition now is kind of part of natively within Kubernetes as CRDs. So you can push the CRDs, or as part of the build service, it automatically pushes those CRDs to Kubernetes, and you can build your images out of it.
By the way, if anybody in the room isn't aware of Kubernetes and wants to learn, there's a company called Udemy, UDEMY. They have training on sale for $9.99.
Which ends today, actually tonight.
No, it ends today. Yeah, so
Nice.
sign up and get your 10. It's excellent. It's excellent training if you want to learn Kubernetes, which a lot of people want to learn Kubernetes, but what we run into.
So apart from the enterprise benefits that we already talked about from Buildpack perspective, Pivotal Build Service also adds the construct of RBAC control and teams. So you can define teams within Pivotal Build Service and have RBAC control over on that team, and then hand that over to your development teams. And those development teams, where you're handing this configuration or RBAC control environment to, they will be able to kind of operate within that team. So you can say team 1 has a builder for Node and Java. Team 2 is actually a Python team, so I have a builder for Python associated to team 2, right? So you can build these RBAC-based teams with PBS, and the individual teams can log into their team, log into PBS, and if they are associated with that team, they would be able to use it. And they would be able to use what they are configured to use by the operator team. So that's some of the additional things which Pivotal Build Service adds on top of the Cloud Native Buildpack. Yeah. So to just give you an overview of the way it works is the Buildpack with runtimes and stack-based images is driven by the operators, and your source code of the application and some user-specified context like environment variables and such is driven by the developers. And that together goes to the build service, and it creates the image of streams of images, which is like it's just a view of showing what pretty much Pack was doing, right? In this scenario, it's kind of helping both the dev and ops team to have that separation of duty and show you visually how it separates. And I'm going to walk through this demo, and this is just showing like what I'm going to walk through. So Alana, who's an operator, is going to log in to Pivotal Build Service and create a team over there, right? EV teams, user add, and add users to it. Once Alana has created the team, Cody, who's the developer, he needs to build his Docker images, or there's his application. He would just go through login to Pivotal Build Service. He will apply an image configuration file where it will say that which thing do I belong to, what's my source code location, and what's my image tag which I want to push, right? Once Cody applies that information to Pivotal Build Service, Pivotal Build Service will take that, and Pivotal Build Service will start building your containers and pushing it to Docker registry. Now, every time Cody commits code and pushes it to the repository, Pivotal Build Service will pick it up and start building the image. Now, you can, if you want, you can, in your pipeline, as we saw, you can split this, and you can say that I want to automatically build the image at commit. You can run it through pipeline and say, run it through pipeline where it's first going to do the package, the test, security scan, and then it does the Dockerize and build. Right, so you can split it out that way. If it works for you, you can let it auto build the service every time you make a commit. So you can choose either or in your patterns. And then you would go deploy your application, right? Another example scenario, in this case, say you have CV in JVM and you want to patch that, right? What Alana as an operator is going to do is, Alana is going to do something called as Duffel relocate. Duffel is a CLI which does the cloud native buildpack installation. So Alana is going to do a cloud native Duffel relocate for the JVM issue, which pushes that thing across to the Docker registry. And once that pushes the Docker registry, Alana is going to say Duffel install, and Pivotal Build Service, as I was saying, is going to go build through and update the image manifest, which symlinks the layers. So it's going to go and update the images of the applications. And once that is done, Cody can now run through the pipeline to redeploy the images. So Cody didn't have to go and rebuild all those images, right? It was done just by Alana as an operator updating the JVM. You still need to go through the deployment, you still need to go through the test, but it improves the lifecycle time of build a whole lot by just having Alana as an operator update the layers, which is not really application, but it's the layers above that. And then Cody goes through, whoever is a developer for that application goes through their deployment pipelines. So what I'll do is I'll quickly show you a demo of the first use case where I was as a developer, I want to build this, right? So let me go here. So as an ops team, the first thing which I will do is I'm going to build a team. I'm going to show you an example of this. And this is an example team. The next version of CLI, I haven't downloaded that yet. You can push these as secrets, so you don't have to put it in the team file itself. But what you're seeing over here is this is the team name. This team has this Docker registry, and this team is going to use this repository. And you apply to that team. So let me do a PB login. Let me see if I can find one. PB login. Yeah.
By the way, our DNS says G-Cloud, but it's actually pointing to our
Yeah.
So don't be
alarmed.
We're just using that.
What's the password?
E1V0TAL.
Yeah, I got it. Cool. Log in. So I applied this team, and now think of it. Once that was Alana who created this team for me. Once the team is created, sorry. I don't know.
Muting your laptop.
There's no way to mute it. I mean, I tried muting it on different ways.
On here.
I did that even then.
All right.
It doesn't do anything. So
Okay, I believe you now.
in case of this from dev team point of view, I have this. I was saying the image configuration, and all I'm saying that image configuration is what's my repository and where I'm going to push it as my Docker image, right? And all I do is pv image apply -f and what is the name? Web. Cool. No sound. Apply this. So once I applied this, right, now in this particular example, it will start building the image for me. And I can look at it by doing this. Build. So, right, it started right about, is it 20 minutes? No, it's not 20 minutes. Hasn't started yet. Let's see. Let's go to my Docker registry and see if it's already doing something. All right, it's not doing anything right now. Okay, let me do this. Yeah, that's not. Okay. To image.
Before I came over here, I deleted all non-running containers.
Okay.
Yeah, I was trying to clean up a little bit.
It does not exist. And simply is not the right one. What? Okay, let's quickly try one more time.
See if we have any images.
There's no images.
Okay.
So wow. Okay, let's see if it does anything this time. All right, so it's building now, 29,752, which is close to,
So now you can look at the logs.
yeah. So you can also do is, build and logs, honestly, no, sorry, not that's the image logs. Okay. All right, something happened to it. It's trying to build it, but something happened to the environment, so it's not building. It's going to, oh, it started now. There you go. Slowly started, but started. Right, so essentially, once I applied that image configuration, it's building it now on its own. And so every time I do a commit in this scenario, it will go and build the image again and push it across.
So one difference, so the three scenarios we've shown so far, Hack that did all this on his laptop. The pipeline I showed, it did all this as a task in Concourse. PV is now doing this as a workload in Kubernetes itself. So the work to do this build is run as a pod. And it's run as a Kubernetes job. So every previous run, you can go back and look at Kubernetes and see what did it do, unless somebody comes in and deletes all the containers there.
No, yeah. But so the what we are trying to showcase over here is that we have Cloud Native Buildpacks, which is open source, right? So let me go here. So we have Pivotal Build Service Enterprise version utilizes these components, right? Cloud Native Buildpacks, the homegrown case resource controllers, which I'm talking about the CRDs, and the our backend multi-tenancy web teams, right? So it adds those two things on top of the open source project, and also adds support for it, right? And that's what we are doing with the enterprise version. But here's the kicker: the Cloud Native Buildpacks is already open source, and it's part of the CNCF project. What we have done is, whatever we have done apart from that on PBS, we have what we have done is the homegrown KH custom resource controllers. We have open sourced it as KPack. Right? So now KPack is something which is the second part of the EBS enterprise service. Enterprise version is also open source, the CRDs, and you can actually go and use it. So whatever I did as part of the PB through the enterprise version, you can do that with the open source version using KPack. So Pack, CLI, it was just doing the local way of building things. The pipeline which Mike showed, it kind of used those open source construct of Pack and built it through pipeline. PB adds those two things to it, out of which the KPack, the custom resource definitions, are also open sourced. So the thing which I did where you applied an image, you would be able to do that, apply an image to your, for your containers through KPack, and it will build the image the same way PB did. Right, so the only piece which you don't get as part of that is the RBAC and multi-tenancy with Teams. That's something which we are still, which is still part of the enterprise version. But you can take this open source KPack version of what PB is doing and build your own RBAC around it, right? And try to manage who has access to what builders. And essentially, two things which this KPack does is the builder CRD and the image CRD. So you can have the definition of both. What build packs I want to associate with my deployment and what image I need to apply, or image configuration I need to apply. So you can find more about KPack at this URL at GitHub. So essentially, we talked about what four different things, four different constructs which kind of lays down the story of build service, right? We started with the cloud native Buildpacks, which is open source. Then we went and looked at how we can use that open source cloud native Buildpacks and build our pipelines and lifecycle around it. Right? You can use that, right? You can try to use that and just go from there. The third thing which we looked at was the pivotal build service, which is the enterprise version of cloud native Buildpacks, which adds the RBAC capability to it. And along with that, to add that RBAC capability, we build these custom resource controllers, the CRDs, which does the building and image creation. And the fourth piece is that the custom resource definition, which we created as part of the enterprise version, that's also open source, so you can use that model as well and build your own RBAC and use it for your projects. So you have choice of going to different layers of these open source projects to use it in your projects. So yeah, that's all I had. These are some of the resources we'll share this presentation across. Some of these resources are where you can go and look at and read about it and get to know about it, and you can play with your local environments. Start maybe playing it within your local laptop and see how it enables and makes your local development faster, right? And then you can go from trying it out on your dev environment or something like that.
If anybody wants any follow-up on any of this stuff, I guess you can find us through Meetup, through the Meetup.
Yeah, you can ask questions on the Pivotal Meetup group, and we'll connect with you.
That's all we got. Anybody
any questions?
Comments or questions? Did you learn something? Okay.
Any opinions of what you saw and what you are doing and the difference between those? And
yeah, we'd love feedback.
Yeah.
If anybody's got any past experiences to compare to.
A lot of these tools we need, but really well thought out.
Cool. Thanks. We're not taking credit for building it though.
Yeah.
All right.
Thank you so much for coming in.
Probably lots of pizza left back there, isn't there?
Yeah, feel free to get some pizza and take it with you home.